So welcome really everyone to this workshop. It was organized within the usage project, and I will start with some introduction about the OGC, which is the institution where I am working on, that is in charge, the reference organization for the development of the SensorThings API, and is also organizing this workshop together with the DataNext and the usage project consortium. So, yeah, I work for the OGC, the Open Geospatial Consortium. The activity within OGC is various, then I will give an overview about it, but especially we are focusing on providing technologies and structures and the tools towards the fair data and fair science, fair technology. Fair means findable, accessible, interoperable, and reusable. So it's not only open, but it's really about providing data, information, exchange it in a way that is really enabling the uses, the applications that allows us to support all the challenges that are nowadays there, such as the Green Deal related challenges, the climate changes, and so on. As I mentioned, it's a global consortium where there are many members from several sectors, and we mainly develop standards for supporting such interoperability, such exchange, and fair science and tools within the geospatial world. First mission of the OGC is about standardization. So we try to provide good standards and usable standards through discussions within the working groups. We develop the standards and try to identify what are the requirements from industry and from users in order to align those with standards. For doing this, we are also using the innovation section of the OGC, where I am actually working. I forgot to record. Okay, I will start recording from the next part. Sorry. So where I am currently working. Well, no, I start recording now. If anyone has concerns, please let me know.
This conference will now be recorded.
Okay, so I was presenting the OGC, and I am working in the innovation part of the OGC, where we are working on projects and doing research, real research, together with other organizations. We look for interdisciplinary and intersectoral collaborations. We want to work with our members and to test really what are the standards that are useful, how to develop them further, what are the new needs, and so on. And finally, the third part of OGC is about problem solving and building communities. So within the OGC, we don't have only the standard working group, but also the domain working group within which you can come and exchange about the needs of the community-related applications and challenges. So we can develop together best practices and how really to use standards for the good use and advantage of everyone. These are the three souls of OGC, and something that will come will also be something about education and training. So the OGC Academy is about to be designed and developed, so you will hear about it soon. Talking of this, so this workshop fits within two of the three parts of OGC. So first is about innovation, because we are participating as the innovation program within usage. Oscar probably will tell about it later more thoroughly, but it's a 3-year project. It's an Horizon project funded about the data spaces for Green Deal. So it has started last summer, 2022, and it will last for 3 years until 2025. The goal of usage is about enabling data search, data access, data processing, and making a prototype of a data space that can support Green Deal-related applications and use cases. You can have all the information in our website. And about the standardization role of OGC, we are developing the SensorThings. Within OGC, the SensorThings API and schemas are developed. So these are intended as supporting as a support for interoperability about the Internet of Things devices and applications over the web. Okay, so I am already with a bit late, so thank you, and I will give the word to Marco Minghini from JRC that will introduce us SensorThings in Inspire. Marco, I will allow you to share the screen.
Thank you, Francesca. Yes.
Yeah. Okay, let's share my. I cannot find you. Yeah, here. Okay, thank you, Marco. Please go ahead.
Okay, let me share the screen. Maybe get rid of. Do you see the full screen now?
Yes, we do.
Okay. So good morning, everyone. First of all, thanks a lot to the Usage Project Consortium, to Francesca, to Pier Giorgio in particular for the invite and for the opportunity to participate in this workshop about SensorThings API. I work at the JRC in the team responsible for the technical coordination of the Inspire directive. So we take care of operating, maintaining, and also modernizing the Inspire infrastructure in strict coordination with the policy master of Inspire, that is the Directorate General for Environment. In this presentation, I will basically show you what we did with SensorThings API and how we included it in the Inspire technical framework as a good practice. So let me start from here. This is a report that we published at the end of 2021, so still quite recent and relevant. It's a science for policy report. That means it's not really for technical people. It's also for technical people, but it's also for policy makers, project managers, and everyone with an understanding of geospatial data sharing in general. And it's a report where we provide our vision for the future on how we want to modernize Inspire and how the future of Inspire and of spatial data infrastructure should be. We do that by, first of all, reflecting on what has happened in Inspire in the first 15 years of implementation. You know that Inspire entered into force in 2007. Of course, we learned a lot since then. Many things worked well, many things didn't work so well. So we really take stock of the situation. And then first, we assess the new political context that is around the twin digital and green transition. That is exactly what the Usage project in a way is addressing. So the European Green Deal data space and the policy context in Europe, but also the technological context, which is totally different from what we had 15 years ago. And based on this and based on the lessons learned, we closed the report by developing our own vision for the future of, again, Inspire and SDIs. And also we try to list a number of concrete actions on how we can achieve it. In a nutshell, this is the vision. So these are some conclusions from the report. Data sharing and we could also say interoperability is not a goal in itself. but they are a means to an end. And the final goal should always be to take better decisions to innovate society. And we say that to be sustainable, to remain sustainable in the long term, but also to remain fit for purpose to the current policy agenda, INSPIRE should more and more blend in with the broader IT ecosystem that exists and that is composed of spatial and non-spatial data, but also policies, infrastructures, institutions, technologies, and so on. Only in this way, INSPIRE could really attract a broader community of stakeholders and address an increasing number of use cases. INSPIRE could, in a way, enable its entry level also to non-geospatial people. That could happen only with some ingredients, for example, making the INSPIRE governance more flexible and more agile, but also by facilitating technical approaches for using or for sharing the data, and adopting standards and technologies that are proven to work in practice. As I said, there are also some actions that we listed in the report. You can, of course, have a look at the report and read all the details. Here, I just want to focus on some of them that are relevant to the presentation and to the role of OGC SensorThings API. From the organizational or governance point of view, we would like to have a governance in INSPIRE that is not really top-down, that is not bottom-up, but that is really distributed across multiple levels, that is co-designed. It's an ecosystem approach. So we don't want only the data providers that have been the almost only actors involved in the INSPIRE governance so far, but we would like to have more actors that together interact and generate value, and they co-design really solutions. From the more technological point of view, we would like to ensure always the technological neutrality, avoiding vendor lock-in, of course, but also embracing standards and technologies that are already adopted and already shown to work in practice and to bring benefits. Avoid custom extensions of standards so that INSPIRE requirements can be satisfied by out-of-the-box solutions without extensions. And finally, embrace well-documented and standard-based APIs. Of course, OGC SensorThings API is one of these. So this leads to the concept of INSPIRE good practices that we have introduced exactly with the purpose to modernize the infrastructure. It's not just a matter of substituting old technology and standards with new technology and standards. It's a bit more. We would like to adopt new technologies and approaches that add value to the infrastructure, that generate some benefits, that simplify the life of the users of the data and the providers of the data. What are good practices, actually? These are anything ranging from new technologies or standards or, in general, approaches for data sharing and or for data encoding. They typically derive from the experience gained from 15 years of implementation. For example, in INSPIRE, we used to have the thematic clusters platform. This was a forum with domain-specific discussions and a lot of lessons learned and a lot of feedback, a lot of good practices in the INSPIRE implementation emerged from that forum. In the screenshot, you have an idea of what are currently the INSPIRE good practices. Some are candidates, some are endorsed. I will explain later what is the difference, but you can see good practices around data encoding. You can see, for example, GeoPackage on the left. You can see SDMX on the right, for example. Good practices around data sharing, also OGC SensorThings API, but also, for example, OGC API features, and a lot more. Now, who should propose a good practice, who should endorse, who should create it? This is a very important point. It's not the JRC, it's not the Commission that puts the focus on one technology or another and defines and takes care of introducing something or changing the INSPIRE technical framework. It's the community, it's the stakeholders. So we would like good practices to be community-driven and community-initiated initiatives. And we do that by using collaborative platforms, in particular GitHub, that we are using now for the whole INSPIRE infrastructure, from our help desks to our good practices, to our discussion forums, and so on. how to actually submit and propose and have a new good practice in Inspire. There is a stepwise procedure. The link below points you to the page where this is described in detail, but basically there are 6 steps. Initially, there's an initiation, so the group of people who would like to propose a good practice, typically the group of people who are familiar with the new technology, have to fill a kind of a good practice speech that explains what the good practice is about, what benefits it brings to Inspire. Then there is the first step of the submission as a good practice candidate to the MIG-T. The MIG-T is the technical subgroup of the maintenance and implementation group. That is the main governance body in Inspire that is formed by representatives of the member states. If the good practice is endorsed as a candidate good practice, then there is an outreach phase. That's very important because this consists in a webinar, typically where the good practice again is explained to the community, advantages and disadvantages are described, and evidence of implementation, existing implementation, is also provided. That's a very key factor. We don't want simply to embrace a new standard or a new technology, but we would like to also see how this works in practice. So evidence of implementation, evidence of benefits is crucial. After that, the good practice can be submitted to the MIG, clearly taking into account possible comments from the MIG-T and or from the community. After the outreach phase, the MIG endorses officially the good practice. Then there are 2 additional steps. The first is the legal scrutiny. That's very important because, you know, Inspire has a very wide and comprehensive legal framework, the directive, but also a lot of implementing rules. So we need to be sure that the specifications of the good practice do not break, do not conflict with any legal requirement under this complex legal framework. So this is just a quick legal scrutiny, typically done by DG ENV, the Directorate General for the Environment. And finally, there's the feedback. That's very important. Feedback is, in a way, a continuous step that doesn't end. It means keeping the good practice alive, keeping the repository alive, providing continuously feedback on the implementation, provide evidence where the good practice is used, and of course, solving possible issues, new use cases, and so on. Now, moving to OGC SensorThings API, the good practice proposes it as a new Inspire download service. Clearly, this is an alternative to, in general, OGC sensor observation services and allows to serve dynamic data from sensors. OGC sensor observation services is already clearly an Inspire download service. The idea of the good practice is to propose an alternative, not a replacement. The benefit, of course, is the much easier way to share data, the possibility to perform complex queries, and so on. So I don't spend time here explaining the standard. It is aligned, of course, to the W3C data on the web best practices. More in detail on what the good practice is about, it basically deals both with the data encoding aspect and the data sharing aspect. From the encoding side, the data model of SensorThings API that Francesca has quickly showed before in a slide was proven to be aligned with the requirements from the environmental monitoring facilities, data team in Inspire, and to the observation model that is used in Inspire that derives from the Inspire generic conceptual model and in turn from the OGC observations and measurements. So there is a mapping. I mean, the mapping works. There is an alignment, so nothing really extra to do. The same is for data sharing because the REST-based approach used by SensorThings API that is modeled on the Open Data Protocol standards is also aligned with the Inspire requirements taken from the implementing rules on network services. So this is in a nutshell what you should do to propose an Inspire sensor, an Inspire good practice. So you need to make sure that what you propose is in line with the Inspire legal and, in a way, technical requirements. And this is exactly what was done for OGC SensorThings API. Some content around the good practice. On the left, you have the full page, or actually an extract of the full page of the good practice. There's the link. There you have all the links, so you can just check everything in detail, but this is where the good practice is explained, the benefits are explained, there are also links to existing implementations. On the right, you have the GitHub repository, or again, an extract of the readme of the repository. Here you can find all the content and all the links, again, to implementations and to the technical details. In the middle of the slide, there's a paper that somehow was instrumental to the submission of the good practice. This was from 2018 and was co-authored by several people that are also here in the workshop. I see Kati here, Steve, Hilke, Sylvain, and others. So my colleagues Alexander and Michael. And this, in a way, was anticipating the good practice, because it was, I think, the first tentative to see whether SensorThings API could be aligned with the requirements of Inspire. Now, I will spend just 1 minute to explain the API for Inspire project. This will be presented later from Kati, as I see from the agenda, but I think it's quite important here to mention, because this was also instrumental to the good practice. It's a study funded under the ELISE action of the ISA Square funding program of the Commission that we launched some 3-4 years ago. The objective of the study was to evaluate the feasibility, the advantages, disadvantages, the implications of using new API-based standards, in particular SensorThings API for dynamic data and OGC API features for static data to serve geospatial data within Inspire, thinking on the investments already made by member states to implement Inspire. So how can we move from, in a way, the legacy infrastructure to a modernized framework? And we explicitly required to address different use cases on a cross-border level and, if possible, in multiple domains. The work was very well done, a lot of good results. Here you can see some of them. On the left, the technical report that is publicly available. On the right, there's a website that is basically synchronized with the repository that Kati is maintaining, and provides all the results on the project. Again, links to the implementations. There is also a part explaining the standard, and also in the middle of the slide, you can see basically a link to a workshop or a webinar that was done within the ELISE series of webinars, and that corresponds to the outreach phase or step that I described before. So this was exactly the moment where the good practice was explained to the community, was described. Again, there was an initial session on description of the standard that I would really suggest to all the newcomers in a way, and this was followed by an explanation of why this is useful in Inspire, the mapping, and so on. Final slide is about the next steps on our side in order to follow up with the good practice and in a way to complement its adoption within Inspire. We will add support for it. First, in the Inspire GeoPortal. Inspire GeoPortal is the point of access to all data shared by member states under Inspire, but also in the Inspire Reference Validator, which is the tool we use, the reference tool that member states and everyone uses to check compliance of resources, data, metadata, and also services with the Inspire requirements. Also, a very interesting initiative that is currently ongoing is another good practice, and this is on JSON or GeoJSON encoding for the data. That's important, of course, for SensorThings API, where JSON is the default encoding. So feel totally free to intervene and to contribute to this activity that is currently really happening now. Final point is really something for you as a consortium, as a project. As I said before, the good practice the good practice process ends with a feedback step. Feedback really means keeping the repository alive, showcasing implementation. So please tell us where the good practice, where the standard is used in practice to serve Inspire data, and also provide feedback on the implementation. Does it work? Are there issues? Anything to discuss, and so on. So this is very important, and we really count on you, given the important and the central role of the standard in the project. So that is it, and thanks a lot again.
Thank you very much, Marco. We'll for sure take your invitation to provide feedback and collaborate together with that. Thank you for it. Maybe you can ask questions to Marco later after the other presentation, so we have the overall overview of the implementations. So here is now how to proceed. Yeah, sorry, today is really hard. Yeah, here today, here is the, well, let's do like this. This is the rest of the program for today. So after this interesting introduction from Marco at the JRC and SensorThings in Inspire, we'll have a round of presentations and overview about the available implementations and also success stories, because it's also about how these implementations are used in some concrete cases. And after some question and answer session and a break, we'll have instead a round table with some invited participants from Italian authorities and public administrations about within which we can discuss a bit more how to bring these technologies into practice. And we'll finish with some presentations about the EU projects that are planning to use and develop further SensorThings. So now these are the next speakers for the next session. Steve Liang unfortunately cannot present live, but has sent a video about his developments. Then we'll have BRGM France with Sylvain Grelet and Michael Bofill. Fraunhofer Institute with Hilke van der Schaaf, Datacove, Katish Light, and the next with Luca Giovannini. So I launched the video. Please give me any feedback in case you are not able to listen or see it. Okay, nobody's able to do anything at the moment, I think. So I open it again. Why am I not hearing anything? Wait.
Sì, sì, fa partire.
Ma non c'è il video, non c'è l'audio. Okay, so hoping that we can proceed to the following presentation, and then we try to fix the issues. Sylvain, I think it's your turn. I allow you to present.
Yes, a quick request from my side. We've been discussing background. We'd agreed that my talk would be the first one because I explain the logic of the model, and then Siver can continue with the details, what he's done with it.
It works.
Is it okay to reinstate the original order? I think that would help everybody. Give me one moment and my presentation will be ready.
Yeah, I think it makes more sense. It will give a more context, technical context, what we're presenting afterwards.
Yeah,
Can you give me a presentation, right?
Is it working?
I can't present yet. You have to make me presenter, please.
No, non va più. No. Sì.
È in pausa.
No. No, non mi fa male.
Sì, magari lo facciamo dopo la pausa, proviamo a capire come funziona.
Sylvain.
No, Cati.
Katy. Perché Katy?
Ha detto
If you make me presenter, I'll go on. But
Are you... Well...
ha detto che prima di partire lei.
It seems the only organizer is having technical difficulties and cannot make it.
Who is the organizer? Yeah, indeed. Who is the organizer account of the webconf? Because we're having a red banner on the top of our screen saying that organizer meeting technical difficulties and the session might end soon if the organizer then does not join back. Is that Marco Falconi, the organizer?
No, it's me, but it's Francesca Nardo, but GoToMeeting has quit, so I'm not sure who is now the organizer. I'm reopening it.
Oh, the organizer is back. The red banner. Oh yeah, we see you twice. That's stereo mode. Keep that.
Si deve rimanere perché sennò
lo so, però... Okay.
Could it be
I
that
think now with Francesca account you can design presenters now?
Okay.
Katy,
please go ahead and yeah.
Okay, why am I on this slide? Sorry.
Take it out.
Sorry for the confusion. I'm Katy Schleid from Data Cove, and I'll be bringing you some information, what we've been doing, what we did in the API for Inspire project, and specifically more details on the SensorThings API. Sorry for being a bit geeky, but it's to give you a basic overview of how does the SensorThings API actually work. If you want all the details, look at Marco's presentation. He's provided you all of the recordings of the various training sessions we've done. So, API for Inspire, this was a project, as Marco already mentioned. We evaluated both the OGC API features and OGC API SensorThings for use within the Inspire context. Both of these resulted in Inspire good practices. So now both of these APIs are good to go within Inspire. At the bottom of the page, you've got the link to the API for Inspire webpage. There's basically anything you never wanted to know about SensorThings is there. We've tried to do a totally complete tutorial. So anything you'd like to understand better, check it out there. And also, as Marco mentioned, all of this work was funded by the Elise project as a way of moving Inspire into the future. OGC SensorThings API has been an OGC standard since 2016. And the version 1.1, which is essential for working within Inspire, was approved 2020. Once we got that finalized, it was no problem finalizing the good practice. It's got a very nice, simple core data model really embedded in the API. That's a major difference to the normal OGC APIs, which just say, provide features, provide tiles, provide records. Here we have a basic core structure, and that's based on the OGC observations and measurements model. And this is one reason it was so easy to transfer the Inspire data models to SensorThings, because the Inspire data model is dealing with dynamic data. They're all using the observations and measurements. Since SensorThings uses the same structure, it was very easy to just do the mapping and everything ran. The further bit about it is it's a wonderfully powerful API due to the OData protocol. So it allows some really cool queries. I'll give you some simple examples in a few slides later. And what's really nice is, it's called SensorThings, but it can be used to provide basically any type of observational or measurement data on anything. So you really don't need a sensor. And with an API for Inspire, especially since that project, the moment we started, COVID showed up on the scene and we had no events and lockdown, and we had to be creative, and we started thinking out of the box, what can we provide? And a nice series of things I won't be presenting here, but it's all available from the site, is we've gotten information on air quality and COVID, strong links there. We knew all of the European air quality data is available via Inspire structures. We had 2 long nights and managed to transmogrify the data to SensorThings, had that online. But that really just started getting us going, because then we had the air quality. Then we had the idea, wait, there's all this information on COVID, how many cases, how many vaccinations. That's also just an observation on the thing. So we set up a second endpoint, all available via API for Inspire, providing number of COVID cases. This got us to a really creative point, because then we realized the number of cases isn't relevant if you don't know the population of the region. And so we put up a further endpoint, taking the demography records from Eurostat. And again, we could nicely align these with the spatial units and NUTS regions, provided via SensorThings, and it's there, it's available. Go to API for Inspire, and you can see just how far out of the box you can play with SensorThings. But now going into the details. Here we've got the SensorThings data model, which has already been shown. And I'd like to walk you through what do these individual boxes mean. So the core thing with SensorThings is the thing. This is some real-world object where you have your sensor. It can be your monitoring station. It can be the room where you've got your thermometer. And sometimes we actually use this to also play with what we are observing on. But this is always one of the essential real-world objects in your setup. It's usually the thing you have your sensor mounted on. But again, you don't need a sensor. All things have a location, or could also have multiple locations. And thing locations can also change over time. So, I mean, the direct location provided here is this thing is exactly here. However, a thing can have multiple locations. I could do one location which has a nice GeoJSON object. I can do a second location which provides a description of the address. I can provide a third location which, let's say, has a wicked encoding of the location. And if my thing starts moving, I mean, this can be something mounted on the ground, but this could be a drone. If the drone moves, it is constantly somewhere else. In order to keep track of where it was, we've got this historical location type, and all locations which are no longer applicable are still retained via the historical location link, and therefore you know where is your thing now, and where has your thing been over time. Okay, so now we've got the thing and where it is. Now going on to the data stream. This is what pulls together what type of information are we measuring from that thing. So this groups together the various other bits we see here. I'll describe them in more detail later, but it says this thing is linked to that sensor, which is measuring the following observed property. The observed property could be the concentration of ozone, it could be the number of COVID cases, it could be the water level, it could be the temperature. That's the nice thing about this model, is you add a new observed property and you can provide data on new concepts. And when you've got all of that strung together, you then provide the observations provided by that sensor for that observed property linked to this data stream. And now we're going into the details. I've already mentioned a little bit. The sensor is the device which is actually providing the values. This could be some electronic sensor. This could also be a person reporting data. We've used this for biodiversity data. This can be the grad students you send out into the field. This can be some numbers coming from somewhere. So, I mean, when we were doing the COVID case data, our sensor were the national repositories providing current data. Observed property is what is actually being provided in the measurement. So as mentioned, this could be temperature, this could be a water level, any type of fact that you are determining on your object, it's your observed property. Then we've got the observation. This is really the core payload. This is where we provide one individual value pertaining to the sensor and observed property and thing described in the data stream. So if we have a time series, we start collecting lots of these individual observation types and attaching them to the data stream. One short note here, we have 3 different times. This often confuses people. We've got the phenomenon time, that's when the thing we measured actually happened. So the phenomenon time is just about always provided. The result time is for the case where you're doing some sort of a later analysis. You take a sample, you send it to the lab, the sample was taken today, you don't get the result until tomorrow. Once you've got the result, you add the result time. Valid time is the 3rd time we have here. And for normal measurements, this is rarely used. It's used in some cases where you say, I've taken a measurement and I say this value, this counts for the next hour. However, where valid time becomes really valuable is when you're doing various modeling and estimation. And that's a further potential usage of the SensorThings API. You can provide information, not just things that a sensor has measured in the past. You could replace the sensor with a model and have your sensor model something for the future and provide forecasts. If you're providing a forecast, you need to provide information for what time period is this valid. Tomorrow the weather will be sunny, then the valid time is tomorrow. And finally, going through this diagram, we've got the feature of interest. These are then the actual real-world objects this is being monitored. So, I mean, if I have water quality, I could have my environmental monitoring facility, I have my sensor attached, it's measuring water temperature, I have my values. Here I've got my little sample or my sampling point. So this is then the explicit object I'm measuring on. Now going into details of the API. So there's a demo link at the bottom. I'll be making these slides available. And if you hit that link, you're basically here at the basic API overview. It's always the base URI plus the version you're going at. That gives you an overview of all data which is available. So you've got a list of all the different classes provided, can click your way there. If you click into an individual class, here we've got the example for things. So if you click on a link on one of the links, add things, you get a list of all the things that are available in that system. If you want to access an individual thing, if you know the identifier of it, you add the ID in round brackets at the end, and then you get exactly that thing returned. So this is the basic way of how do you access things at the API. It's different than OGC API because it's based on OData, not Open API, but it has all the same functionality and way much more. So this is the basic way of accessing it. Now going into how can we tailor our requests, or responses actually. The first 4 I'm presenting here are basic housekeeping. So you can specify how many objects you want returned. Default setting tends to be 100. You do a request, you get the first 100 things. If you want more things, you then need the second request, skip. The skip you can use for paging and say, okay, I have top. I've gotten 100 values back. I can now do a second request saying skip 100, then I get the next 100. However, I can also change the value in top. I can say, I can't cope with much data, just give it to me in blocks of 10. Then you can go through in small chunks. You can then set skip to 10, go through that way. You can also go the other direction. You can say, I can cope with the data, give me 1,000 at a time, I will go through that. Related again to this is also the count parameter. There you can request that you get the total number of features. So this can help you page through it. And this is usually set to false by default because it is a bit processing intensive. So the system is faster if it doesn't, with each request, have to provide you how many it really does. If you want to know, ask, you can get it. Final housekeeping option is order by. There you can point to a specific attribute. You can say, give me all observations, ordered by the phenomenon time, descending, and then you've got the newest observations at the top. So these are basic housekeeping things. How do I page through the stuff? How do I access certain bits? Now we go to some of the really cool bits on the tailoring responses. The first one is the select. And this allows you to clearly specify which attributes of the classes you actually want. So, I mean, if you do the normal default request, you get all attributes we have for that class. However, that's often overkill. So here's a simple example of one of the things from the air things. Is one of the German measurement stations. If you don't need all of this, let's say you just want the name and the description, that's good enough for what you're doing right now. You can use the select request and say, okay, I want this thing, but please just give me the name and the description. And then you get a nice tight little piece of JSON just providing those concepts. So this lets you really access the service, but not just take what is there. You can really tailor it. I just need these little bits. And this way you've got really lightweight data payloads. Second one of these really nice tailoring bits is the filter. The one bit which is confusing, filter in SensorThings is what select would be under SQL. This is where I'm constantly confusing myself. This is how you can create various filters saying, give me all values where this attribute has a specific value. So going to this example, again, we've got the same German station. If I access the endpoint normally, it's the first station that pops up. Let's say I want to see the Austrian stations. I live in Vienna. I want to see the local stuff. So if I want to do that, we've got the country code within our data, so we can filter by the data. And so again, we've got our endpoint. I now haven't specified which object because I don't know which objects are in Austria. But I say filter it on all things where the property's country code equals AT. And the first one that pops up is one of the stations here in Vienna. So that way you can really nicely filter and say which bits do you want, which features do you want returned. Finally, the expand. This is one of the mega cool ones I've yet to see in other APIs. And this lets you really lump the data together as you like it. If you think back to the data model, you've got these 8 different classes linked together. You could view that as a graph. And you can say you start at one class and you go along this model graph and come to the neighboring type, say, I actually want to provide that also. And I want to inhale that. I want to take that in my belly. So with expand, you can start with one type and say, actually give me the second type nested in. So again, starting with a simple thing, I then expanded it to say, I have my thing, I only have the name and the description. I do that by the select as shown earlier. However, I want to see what data streams are attached. So here I see we've got this data stream attached to this measurement station, and I see they're measuring NO2. So that's the data stream I could then use to go to the observation and then get all of the NO2 measurements at this station. And that's it. Now you get to see the really fun things that have been done with this.
Thank you very much, Kathy. Now let's try again with the Steve video, and if it doesn't work, okay, we'll skip it. So present, include, major sounds, share.
Calgary, I've been involved in OGC sensor web enablement, in particular, for a long time. And I'm the chair of OGC SensorThings API Suite and OGC sensor web enablement tool. And I want to share with you my journey and what we are doing at SensorHub, but also how to build a sensor web solution for positive global impact. Okay, a little bit about the company. The story is this: I'm a professor involved in the standard making, and at the very, very beginning, on the right-hand side, you can see actually I took this picture back in 2004, and we worked together in a small room near in Washington D.C. and then how to build standards and to enable a sensor web. So it's where it started back then. And we developed the standards, different versions, and then I implemented all the versions. So learned a lot of lessons. And then I was like, okay, how can we share the lesson and to have a real impact, right? So I was like, start a company. So let's start a company to show, okay, my thesis, okay, my concept, and what can be done to show that. So I started Sensor Up, and then we started 2011, but didn't have much going on. But 2014 we have our first customer, and then start to to build technology and build a team. Right now we have about 30 people. We are funded by venture capital, so we're ready to round of financing. Hopefully we'll close another round this year. And then our mission is really building a sensor web, make its information accessible and useful, and for positive global impact. And hopefully today I can share some use cases and our thesis about this. So SensorThings, or sensor web enablement, right? It's a core, but just the start. It's not just the end, right? So we're like, okay, how can we build an ecosystem, a tool chain to use the sensor web information and to build solutions, right? And so we have a product called Mission Control. It's a desktop user experience, right? And then we didn't call it a dashboard or viewer. It's a mission control. It's not just about data. It's like after you have data from sensors, so what? After you have dots on the map in real time, so what? We believe actually it's important to have a solution to trigger operational execution in the field. So you can have a loop, data, prediction from the models, and to get operational execution to get things done, and the sensor to validate the action has happened, right? So it's called mission control. It connects everyone in real time. It enables someone in front of the desktop to work with the sensors and work with people on the boots on the ground. And one key component is, again, to answer so what question is like data, so what, right? We have a no-code, low-code workflow engine, so drag and drop, and allow users to really, okay, data comes in, and so what, right? When the person enter in a geofence and notify somebody, and then when a rail car enter a geofence, like a rail yard, and we dwell for more than, for example, 24 hours, right? Send notifications, so on and so forth, right? So it's really about answer the so what question. And such workflow, we believe, is a core component to stitch different information and actions in the sensor web together. And from a desktop user experience, right? So how can the user in front of the screen and work with the field? So we developed this as a empower human as a sensor and actuator, right? So it's outpost to protect user, but also get things done. So offer digital field experience for workers. And for example, you have a firefighter, for example, can use the outpost, right, and to detect the fatigue and stress and the heart rate. And by the way, with outpost we have both Android and iPhone, and as well as the Apple Watch and the Samsung Watch solution. It's really enable the field execution, right, from the sensor to the predictions, and to human have a judgment and work with the field workers to get things done. We believe it's a very critical component for such sensor web. Again, the question is like, so what? What's next to get things done? Okay, short video to show you what how we're doing. Okay, so one question I always in my mind is, what are the pressing challenges or problems that human race we are facing? It must use a sensor web as the solution. That's a good question. I think so. And then, so that's a good question. So this is the question a message I want to leave, here and to, share with you that what problems we are facing today, you must use a sensor web as the solution. For example, we found one, methane emissions reduction. You must use multiple sensors from different systems and work together, and then to basically detect, and then so that we can dispatch people to repair them, and then to get things done. And the sensor comes back to validate it, right? It's been repaired. So methane emissions require satellites, drones, airplanes, towers, vehicles, and people, boots on the ground. And so actually right now SensorUp is really much focusing on building a sensor web to reduce methane emissions, from sensors to predictions to modeling and boots on the ground, get things done. And sensor to detect again and have the loop like this, right? Okay, so if you forget everything you see today, I just want to leave this message to you. Okay, what are the problems that we must use a sensor web to solve so that we can have a positive global impact? Thank you.
Thank you, Steve. And now Sylvain. Okay, I made you presenter, Sylvain. I think you can share your screen. I start the recording again because it had stopped when I crashed. Okay.
Hello, everyone. Can you confirm you see my screen properly?
Yes, perfect. Thank you.
And the good one, I suppose, I guess, the slideshow. Okay. So I was told to give you a feedback on SensorThings implementation. The title in the schedule mentioned water, but after discussion with Fernanda, an organizer of the workshop, I'm gonna give you feedback on the dynamics regarding SensorThings in France, because we're having important dynamic there. That's also a journey somehow. I'm reporting a bit like what Steve was just doing right before. We started to prototype SensorThings API in 2017, 2018 on the French groundwater level monitoring system after having contributed to the spec at some point. And progressively, they started to accelerate and have more and more impact, and parties interested in that. We moved to, and I'm going to, we will have examples afterwards, but so that you actually remember that's an important dynamics in journey. We moved to the year afterward, prototyping and actually pushing close to production SensorThings API deployment on the French water quality database and on top of some web services for the National River Gauge system. And we gain progressively more interest from the French National Institute for Ocean Science, that's IFREMER, and the French Agronomic Institute, and then even more growing interest from various French research infrastructures. One on the critical zone, that's the interface between soil, groundwater, and atmosphere. The DATERA is a French research infrastructure on solid earth, environment, and stuff. Plus others. I've just discovered Juan pasting in the chat example from colleagues at CIRAD as well, south of France. And at the end of the day, we had an important national research data workshop dedicated to SensorThings API, and I will reuse and grab slides from this workshop. And we also that one is a bit extra out of France, but broadening the domain implementations through the OGC groups, and I will give you feedback on the geotech and water quality interoperability experiments we're running, and in which we actually do have SensorThings API at the backbone. And of course, all through that journey, always supporting funding, evaluation, and open source communities implementation of SensorThings, because that's the topic of today. So first feedback on the National Groundwater Monitoring System. So the system is the following. We have piezometers monitoring aquifers and acquiring raw groundwater levels. What basically is mapped our national system to observation and measurements because of the semantic backbone, and then to SensorThings API. And we use SensorThings API actually to acquire in that context and re-expose readings from field sensors. So how is it going? We have field sensors that push every hour readings, through GPRS technology. And this comes from, vendor. At that stage, vendors still push their own semantics, but we map that to the relevant semantics. And then at the end of the day, we feed Frost implementation of SensorThings API standard. We use actually SensorThings API to the, I would say, to the fullest in that sense, because we use it as a true RESTful API, but we also use this MQTT sub mechanism to insert observation, and that's really powerful. That's a game changer. That specification is a game changer, SensorThings API. With regard to what we were using within the sensor observation service specification, we used to have SOS here, and we definitely moved to SensorThings API for our national system. Beauty of interoperability, of course, is, just for the sake of those workshops, I just grabbed the one endpoint and data stream, and just a matter of declaring the endpoint in various SensorThings API clients who actually do have access to the same content, which is maybe not zoomed to the same time window, but actually that's exact same sensor, same values and stuff. And even in some clients that are really over the Atlantic, like the Internet of US client. This one is the framework for Web Genesis. This one is actually the client developed for the Marine Agency in France, so that's not tailored to our specific need, but it works. That's interoperable, and the QGIS plugin as well. Then, this deployment is on top of the French water quality database, which that use case is really interesting because it allows to test SensorThings API spec and its first implementation on top of big volume of observation. Here we have 130 million and more now observation in that database. So again, domain model mapped to the generic, I would say, meta model of 1M SensorThings API, which result to contribution to the as a result to the contribution to the API for Inspire project that was already mentioned. So this is just to avoid too much technicalities. That's what domain colleagues can access in a client. So we have next to the others data flows, French and German side of the Rhine River, and that allows to plot station and water quality station here from various information systems, monitoring the same real-world object here. That's the Rhine. Something that was not done, but that's not the purpose of SensorThings API is actually mapping code lists. That's the obvious next steps. But here you have calcium here, you have calcium there, and that allows to plot data coming from two different information systems monitoring the same real-world object. So that's the purpose of our job, right? Allowing our domain colleagues to do their work instead of exchanging CSV file over emails or whatever. Now I start grabbing also slides from our colleague. So the feedback here is what Ifremer, so the I used to say Marine Agency, now apparently their English websites say Institute for Ocean Science. But at the end of the day, what they do is deploy SensorThings API on top of their Argo network. That's an international network of buoys that drift along the ocean, and then they dive, they take measurement at different depths, they broadcast data, and they dive again like that. This is mapped to SensorThings API, O&M then SensorThings API model, and exposed using SensorThings API, of course. What's interesting is that that's a mixture of time series, Z series, because they dive, they take sample, and they also include sample values. Their trajectory, you have that here. And they're so talked about the standard. They also were pushing SOS. They were part of, like us, of the Inspire groups on SOS, but we all moved to SensorThings API, and we also put those ID in various domain projects we have. So this is another screenshot of what Ifremer is doing on their Argo network buoys. That's an endpoint of their API, not the client. And that's the way they handle depending on which properties are monitoring, either trajectory, profiles, and stuff. Our Agronomic Institute in France as well, nationwide, is also doing the same transition to SensorThings API. So that's an example on the National Soil Database. They mapped the historical legacy national database on soil samples, right, to SensorThings API. And that's an example of how organic carbon measurement on a sample, a soil sample, looks like mapped to SensorThings API. And then what they did is they ported their model once the prototype phase was okay and validated, and push that to production. Here they are also using a Frost server. The Ifremer, by the way, was not using a Frost server. They use their own deployment. They funded to a French company, OGC Active, that is called Geomatis as well. And at the end of the day, yeah, on the web client, that's an example on Guyana. You can just click for soil sample plots, and you have the agronomic value for the various soil layers. And as I mentioned in the intro, the interest is growing within, as you saw, a French research organization, but also across organization to share data in research organization, in research infrastructures. This is an example I grabbed from the research infrastructure in France regarding the critical zones. So again, it's really mixing geology, soil, hydro, and the atmosphere for the information. We are working jointly with that research infrastructure to define SensorThings API guidelines to share data across French research organization, that here, that's ingested using SensorThings API and broadcasted again to other systems. And the interest is even more growing. So last year, we had through that list, that is how can I say that? The list we used more and more across French research organization to discuss around fair data. That's interesting because fair data is really more and more important, especially for research organization, but also abroad, as you saw from Francesca introduction on OGC. And we had so many questions about sensor data. Should people stick to source? Should they move to SensorThings? Should they do something else? We had a specific workshop webinar on SensorThings, more an intro one that lasted a day, and you had some of the examples I reused, and we're progressively moving to hands-on trainings and stuff. So that's really nice. We also heard about, I discovered that today. I don't remember how you named that, but that's the OGC, how did you name that, Francesca? The OGC, I will find that, school or something like that, campus. Would be great to sync on that, synchronize on that. Okay, that's a quick overview of dynamics we've got in France. Two of them are stemming outside Europe and through OGC. So we are, quick feedback on two interoperability experiments. So one is the geotechnical interoperability experiment, which is led by BRGM, by my colleague Michael, who is also online. Michael, I think for the sake of time, I just go through the slide. Michael gave me the link to the wiki. That's under the GeoSense Domain Working Group umbrella for OGC, which Michael co-chairs as well. Different members, especially what is important here, it's not on OGC focused. You have Building Smart International, AGS, so it's opening to BIM world, many communities as well, and the context is exposing geotechnical in situ measurements, and here that's a focus on the part regarding using SensorThings API as a backbone. There are different types of measurements. I'm not specialist on those, the acronym there, but that's geotechnics, different types of measurements. There are challenges like sharing Z series, and the fact is that the borehole itself is a reference system somehow, because the measurements are taken along the trajectory of the borehole. So that's an example of a non-straight borehole trajectory, some various geotechnical measurement results. There is another IE, interoperability experiment under OGC. We're also driving with the help of the Internet of Water US. I forgot the US here. This one is under the OGC Hydro Domain Working Group umbrella. A lot of members. You can see WMO, UNESCO, US EPA, various side of the world. Go down also to Australia and New Zealand. Our context here is to expose water quality measurement, surface and groundwater across organizations, of course. That's a mixture of in situ sensor, one-time measurements, sample, and subsamples, and sub-subsamples. A lot of that could go to biota, fauna flora observation, and we have a lot of control vocabularies to deal with. So the backbone of this one is observation, measurement, and sample on the semantic side, and the backbone on the API side is SensorThings API and OGC API feature. So that's also an important dynamic that has been emerging and going on. Last point that is important is funding through all those experiment exercises I presented. evolution in open source tools. So on our side, we mainly fund them first. And I mentioned like ephemeral funding activities and other open source implementation of SensorThings. And we plan as well to port to QGIS the STA plugin coming from the Airbrush project, so that's a complete streamlined round trip from server to client side. That's really a quick tour. And thanks to Katie, Michael, and Milka, and all the colleagues that got presentation to fit content to fit that presentation. If you have questions, let me know.
Thank you very much, Sylvain. Now I give the stage to Hilke.
Thank you.
Okay.
Yes, we could
Hilke,
share. Now everybody sees me double. Always like that. Okay, can everybody see my slides?
Yes, perfect.
Excellent. So my name is Hilke van der Schaaf. I am a co-chair of the standardization group in OGC that creates the SensorThings API. And I'm also the author of one of the server implementations of the SensorThings API called Frost Server. Today I'll give a bit of a live demonstration of some of the implementations in smart city context that exist around the world. So my first demo is from Hamburg. Hamburg has a geo portal, and they have one of the biggest SensorThings implementations that I know of. They manage about up to 10,000 measurements per second. And one of the things they measure is traffic light status. So what you're seeing here right now is lots of blinking lights. And these are actual traffic lights. So here on the top left, we've got a big crossing. And we can see that right now, these pedestrians are green, and now these cars have a green light. Actually, that's the other way around. They're driving this traffic light down here, that's green. So right now, this crossing is green for pedestrians. You can see the pedestrian crossing here changing. And now this traffic light went red, so cars have to stop. So SensorThings API is not just about getting historic data. You can also get push information about the latest measurements as they happen. So, an example also from Hamburg is shared bikes and whether they are available or not. So it's the same geoportal, I just changed the background map. And there they are coming. You got lots of little bikes. So there's bike sharing is quite popular in Germany and in many other countries as well. Of course, if you're traveling somewhere and you're arriving at the main station, you want to know, well, when I get there, can I get a bike? Well, if you get there right now, there is one bike available at this bike sharing station in Hamburg. And here you also see the progress in the last few hours. So at night there are quite a few bikes available, and then in the morning they're all gone, which is quite typical for train stations. This one has the same pattern. And this one is a bit more available. And if you go further away from the train station, there's fewer bikes in total, but you've got more chance that there is a bike available. There's not that much of a peak in the morning. And in the evening, all the bikes are brought back. Okay, this one is also close to the main station. And in the morning, when everybody arrives at the train station, they all grab a bike and go further to their destinations. And another example, charging stations, another one of those things where you want to have the latest information. When you're driving around with your car, you want to know, can I charge my car and where do I have to go to get a place to charge my car? And this image I made yesterday evening, there was quite a bit red. And here there's still a lot of red. But so this charging station has 2 charging points and they're both charging, so they're both occupied. And then here's an example. This charging station has 3 charging points, but 2 don't work, out of order. This one has 3 that are completely available. So this is another example. You're traveling into a city and you want to know where are the charging points. And then it's important to have a standard so that you don't need to download an app for Hamburg just to find the charging points in Hamburg, but then next day you travel to a different city and then you need a different app because, well, different city uses a different API. Well, that's something that the SensorThings API is there for to solve. If all the cities use the SensorThings API, you only need one app and you can find charging points in any city. And here, of course, you also can get push notifications to see the latest change, so that if you're not driving to a station that was reported as being there but has been occupied in the meantime. Another quite nice example from Hamburg is bike counts. Of course, you can count traffic, like in the traffic lights example, but you can also count bikes. And in here, there's a couple of cameras installed on this bike, on this bridge, or on this point. And here are some more points. And these are infrared cameras. The cameras have a bit of AI in them, so that they know what a bike looks like. And so they can detect bikes, and then they count bikes for intervals of 15 minutes and send the information to a central server. So the images themselves are never sent anywhere, and the data is also aggregated before it is sent, so you cannot track individual persons. That was very important for the privacy, of course. And then you can get statistics. Let's see, of yesterday. These are all the bike traffic that passed this point in either direction yesterday. And they've got 2 more points. This is from west to the east, and the other point is from the east to the west. So you can also see, maybe we can actually see a difference here. Always interesting to try. Here we see a sharp peak in the morning when everybody goes to work, and then in the end of the day, the peak is a bit broader, but because some people work longer, some people work shorter. But this is always interesting to see the sharp peak in the morning. Now, the interesting thing, of course, is SensorThings API is an open standard, so you can have multiple implementations that all read this standard. So here's a completely different web system. This is our Web Genesis system for data management. And here I can show exactly the same data. So this is the same point as you saw in the previous map, but a different system for visualizing it. And here I can also show, for instance, the traffic for a week. And so different clients, but the same data. So you can have multiple clients. You can have multiple clients that all read the same data. You're not stuck to whatever app the city makes itself. If you don't like that app, or if you think I have a use case that also needs the data, you can use the data because it's available in a standardized way. Next, an example from Berlin. Berlin also does bike counts. And they use partly the same platform that Hamburg uses. And they also have a nice image of the location where the count is. This is not a live image because otherwise this guy would have fallen from his bike already. And here you can also, it's a bit of different user interface because here you can select whether you want to have the direction, both directions. And instead of having different points on the map, they've solved it with a drop-down box. So in the direction of Charlottenburg or in the direction of Mitte. And here you can also select whether you want to see the hourly aggregates or the 15-minute aggregates. So here there is about 400 bikes in an hour passing by this point. Berlin also counts cars on the highway. So again, same interface. There we go. This is the highway that's going straight through Berlin. And this is the highway around Berlin. And here they use induction loops in the road to track cars and lorries. So if we look at well, today we see about 20 lorries per minute passing by at this point. And oh no, this is 20 cars per minute passing by on this point. And the speed, well, here you saw the speed was quite good. And then there was obviously a traffic jam because the speed was dropped down to quite a lot, to around 30 kilometers an hour. Normally they drive around 80, 90 here. They also count trucks. Oh, there's quite a lot less trucks per minute. And also in the trucks, you can also see the speed. Trucks have a maximum speed of around 80. So most trucks indeed drive around 80. And then here was traffic jam around rush hour. And then it went up again and down a bit. And then it's stable again. A bit more experimental site in the city of Erfurt. We're experimenting with parking garages. So here we've got a parking garage near the center of Erfurt. And there we can also see the capacity. It has place for 30 cars, and then the occupation is how many cars are really there. And then we show it for a week. You can see when it's getting busy, around in the morning, around 8 in the morning, people start arriving, and then they leave again. But usually there's a few spots available. So if you're looking for a spot near the center of Erfurt, that's usually a good bet where you'll find a place. Let's see if the others are all that nice. Different car park, capacity. That's a lot bigger, has capacity of 200. And it seems to be always the same filling level. I guess that's not the most reliable sensor. Oh no, this might be that. It's this one. They had 700 cars in a parking lot with a capacity of 200. I guess there's something not quite correct in that data. Or maybe this is the capacity. This is the capacity. They've got mixed. They've got a long-term storage, a long-term parking with 200, and a short-term parking with 700 places. And here you see, well, it was actually full. They had 715 cars in the parking lot. And also Erfurt is counting traffic. So this is an example of Erfurt loading of Erfurt. Here you see the traffic nets, all the roads, all the main roads. So if we look at the highway here, we can see the count of cars, vehicles per hour, up to 1600. And then at night it's a lot less, of course. And they've got the speed. So the average speed. So during the day, there's traffic jams, lots of cars, low speed. And then at night, few cars, high speed. So here you can clearly see that traffic data, the speed and the number of cars are linked together. Some examples of smart city data, live, online. Thank you for your attention. If there are any questions, I think we've got a question round at the end.
Thank you very much, Hilken. And now, last but not least, Luca.
Hello, everybody. Can you hear me? I hope so.
Can you hear Luca? Probably you have to switch your microphone.
I'm using the room's microphone, but if it doesn't work, so they cannot hear me. I'll use mine. Yeah, I was using this one.
Yeah. Can you give us a sign if it's working?
Can anyone hear me? Can anyone hear me?
A thumb up? Not well. Why not well?
Can anyone hear me? No?
We can hear you through the webcam. No worries.
Yes, great. Please go ahead.
What about now? Can you hear me? Now? Yes? No?
Hilke, you have you are the only one with
It's
your
low.
camera on. So if you hear Luca, please.
Okay, thanks.
Great.
Thanks, Sylvain. Okay.
We are hearing him.
So you hear me and you hopefully are able to see me. Like so.
We are seeing you at least 5 times.
Sorry, I didn't understand that.
Yeah, we are not seeing your presentation.
You are not seeing my presentation. No. That's a problem because the thing here is saying that I'm sharing my screen. Let's try again. It says that I'm sharing my screen, so. Then I'll try again the sharing. Stop sharing, and then let's try again. Start sharing. Oh, okay, sorry. I made the usual mistake of sharing just a part of the screen. Sorry. I blame the others when they do it, but now I did it, so sorry. Can you see it now?
Yes.
Yes, perfect. Okay. So hello everybody. I'm Luca Giovannini and I work for DataNext, and I will present you our own implementation of SensorThings that we have developed in two different projects. Airbrake, project-based partly that has a pilot in Ferrara, in the city of Ferrara, where I am now, and another implementation that we did for Project Highlander, based in Trentino, a region in Italy. Just a very few words about DataNext, my company. It's a software and services company. And we have a research and development department that focuses on many activities, but specifically on those fields related to smart city and sustainability. And within this framework, we developed our own implementation of, well, actually, we leveraged on an existing implementation of SensorThings API. That is the Frost one that we had the honor of listening to them in the previous presentation. So just to be just as a quick idea of what's the architecture that we used, it's centered on the Frost server, and it's fed. We don't own sensor networks. We actually are aggregators. Let's say we developed dashboards that with which you can show and interact with sensor data. So we populate the database behind the Frost implementation, connecting to IoT sources, and usually, in general, we actually go pull data from those sensor sources, and we use Apache NiFi to do this. And then, of course, as it was mentioned, we can then use several dashboards, several viewers, several tools to access the data and show it and interact with it. We have our own GeoPortal, which is called GeoNext. We developed a plugin for QGIS that it's going to be further developed. We will talk a little bit more in detail about this. And of course, you can use whatever else visualization device to connect to Frost. So, as I was mentioning, I will present data and results from two projects. So from Airbrake, we plugged into this type of different sensors. So there's air quality sensors from official measuring stations from local agencies. There's air quality data from stations, from sensors that were installed by the municipality of Ferrara. Then data from bike counters and vehicle traffic measuring units. And also, it's not available yet, but there will be also air quality data from low-cost sensors installed in schools and in private houses from private citizens. Then in Highlander project, instead, we were plugging into sensors, very specific sensors for environmental monitoring, and sensors that monitor the well-being of trees, so things that are plugged into trees to measure how are they growing and how are they doing, basically. Then sensors that monitor the fire risk in forests, and sensors installed on animals that measure their well-being. And of course, we also took advantage of some endpoints that were already available regarding air quality, and specifically the one set up by the Fraunhofer Institute about that's collecting the air quality data from the whole of Europe and from the data collected by the European Environmental Agency. So this is the implementation on DataNext GeoPortal, and what I'm showing now is the sensors, the air quality stations, the stations measuring air quality data in Ferrara. And basically what we did was to develop a plugin that in our intention made it easy to understand. Everything starts from the locations of the sensor, since it is a GeoPortal. Then by selecting a sensor, you have access to the list of data streams, and by selecting a data stream, you have access to the data either in text format or in the form of a time series, of a graphical format. And of course, you can select different time periods, and you can, well, it's not shown, but you can also ask to download the data just the one that you are visualizing, just in case you want to do something more on that specific data. Then, as I mentioned, we also developed a plugin for QGIS, since we felt that could have been useful for other people, and we also use a lot QGIS to test our developments. And basically, it works as other tools to connect to other data sources. So you can save some endpoints, or you can of course add new ones, and then you connect to the data source. In this case, it is an endpoint from the Frost server of the municipality of Ferrara, and you can choose. There's this. We implemented this feature since we needed to distinguish between different types of sensors, and we wanted to keep just one implementation of the Frost server. So we used the property field of that's available for all of the entities to distinguish, to group and characterize in a different way the different groups of sensors. So basically what you see here is the different labels put in the properties field. There's an attribute named organization. We just chose that name for the lack of fantasy. We chose that name, and we value organization with different values, and we use that to group the sensors in different groups. So I'm showing now the sensors from the air quality sensors from the municipality of Ferrara, and that's it. And of course, then you can, similarly to what we have shown before for our GeoPortal, you can select once you have selected the location, you see the list of available data streams, and then you can choose to see the data either in text format or in graphical format. And you can, again, download that specific chunk of data. Of course, the plugin works with every endpoint that follows the standard. So this is what you can have by connecting to the endpoint for the air quality data within Europe, the one that I was mentioning before. And as I was saying, again, the plugin groups sensors based on the values of the property field of the location entity. So here you can choose which of the elements of the property field you want to use to group sensors. Here we chose to group sensors by the field nationality, so that you can actually see them as different layers. And so that's it. Those are the sensors. You can select any of them, then select the data stream and see the data and download it. I saw in the chat before that someone was asking for available SensorThings endpoints to test possible new implementations. So I'm also pointing to the already existing list of those endpoints. And yeah, again, I just want to communicate the fact that we plan to develop further that plugin for QGIS that I've just shown, and hopefully we are hoping to make it as a core component of QGIS, so that's no more a plugin, but something that it's available just by downloading QGIS, the new versions of QGIS. But that's to be done. And then this is just a quick example of the fact that once you have a standard endpoint, then you can create different tools to connect to the endpoint and visualize and show data in a different way. Here we had the necessity of monitoring the fact that the flow of data coming from the air quality sensors to the Frost server was actually not interrupted by any problem, so we needed to keep it monitored. So we developed a very simple web page that calls the API and checks for every location and every thing connected to every location, checks again the data streams that are published, and the last timestamp, the last available observation for every data stream, and it just shows in yellow if there's some data stream that's for which the last data available, the last observation available, is too far in the past. So that means that the new observations are missing. It's a very simple tool, but it's up to the task. It's what we needed. And it was really easy because there was the endpoint already available. You just had to call it and rearrange the information on the web page. Finally, I promise I'll be very quick, just to show you the types of data we have been working on and the fact that they appear the same if you use different tools. So this is data about tree well-being in GeoNext and in the QGIS plugin. Data about air quality, again in GeoNext and in the QGIS plugin, and data about car transits in the two settings. And that's it. And thank you for your attention.
Thank you very much, Luca and everyone. We are very late due to these technical issues that we had, so I'm very sorry for that. If you have any question, you can write them in the chat, and maybe we can find a final slot to answer them. But in the meantime, I would proceed to the presentations of to the roundtable. So I am also very sorry to skip the break. So if you need 1 minute, please run and yes. So I would suggest that we continue to the rest of the presentations, because otherwise we cannot make it. So I do apologize for that. Okay, I don't need to make a sound anymore. So yeah, we can skip now to the following part of today's workshop, which is the roundtable with Italian authorities and public offices. So also go to meeting. Okay, so you can have the break for this 2 minutes that go-to meeting is starting again. And okay, so this part will be more, is intended for Italian authorities to share their practices and the data that they are using, and to share what are their plans for using those data in the future, and for using those data through standardized means. So these presentations will be some in Italian and some in English, as the speakers prefer. And if you agree, can you see my screen? No, am I sharing? I'm not sharing. Okay. So please, the first speaker, Antonio Rotundo from Agenzia per l'Italia Digitale, prepare to speak, and the others immediately after. So there will be this very fast round of three slides, 3 minutes. And yes, so we can start. Let's see if I can.
Thank you very much. Can you hear me?
Yes.
Hello, everybody. I'm Antonio Rotundo from the Agency for Digital Italy, where I'm engaged in the service data management, where I deal with the data, both open and spatial, and with the implementation of data policies defined both at European and Italian level. Next slide, please. My organization, Agency for Digital Italy, doesn't collect and produce data, but it is in charge of defining national rules about data policies and strategies. In this regard, recently the Agency for Digital Italy have defined the national guidelines about open data and the use of public sector information. These guidelines is the implementation of the national decree transposing the recent Open Data Directive. In these guidelines, a specific section is dedicated to dynamic data. That is one of the data type identified in the Open Data Directive as data with a high socio-economic potential. And in the guidelines, the arrangements and the specific requirements and recommendations are included to allow the public administration and other subjects interested, such as public and private undertakings, to implement the arrangements and the dispositions included in the Open Data Directive. There is in the guidelines there is also a clarification, a clarification between the about the relation between the open data and spatial data, and in particular the main arrangements is that dynamic data shall be made available through API, and with the reference to API, a specific reference to the Inspire good practice and the OGC standard is included. Thank you very much.
Thank you. So next is Oscar Formaggi from Agenzia della Mobilità di Ferrara.
Sì, grazie, buongiorno a tutti. Provo brevemente, visto il tempo, a dire due parole anch'io. Lavoro come tecnico all'Agenzia della Mobilità qua di Ferrara, che si occupa principalmente di trasporto pubblico e mobilità in genere. Come focus principale abbiamo quello della gestione del contratto di servizio, che regolamenta i mezzi e quindi la gestione del servizio con il principale attore sul territorio del bacino ferrarese, che è Tiper. Tecnologicamente abbiamo anche altre tipologie di servizi complementari alla mobilità, tra cui anche la gestione tecnologica della mobilità ciclabile. E in questa prospettiva, appunto, abbiamo, grazie al supporto di Deda Group, implementato e distribuito i dati che avevamo disponibili su alcuni dispositivi cosiddetti contabici, che erano ubicati sia all'interno del bacino urbano di Ferrara che in alcune zone della provincia. E conseguentemente abbiamo sviluppato un prototipo insieme all'Università di Ferrara per poter utilizzare questi dati, ecco, grazie, in maniera dinamica, nel senso che uno degli obiettivi che la Regione Emilia-Romagna si è data negli scorsi anni era quella di gestire in maniera informatizzata tutti i dati della mobilità. Ovviamente noi come agenzia abbiamo dovuto prendere questo come nostro obiettivo e abbiamo realizzato un'infrastruttura che ci permettesse di sfruttare questi dati. Inizialmente abbiamo appunto sviluppato un prototipo relativo sostanzialmente solo alla mobilità ciclabile, però il nostro obiettivo è allargarlo anche ad altri aspetti, in particolare quello che ci sta più a cuore, soprattutto per il rapporto che abbiamo con il trasporto pubblico, è quello relativo al ai dispositivi cosiddetti AVM, che sono dispositivi che vanno a bordo mezzo e per questo diciamo sono da considerare importanti per quanto riguarda la rendicontazione puntuale che dobbiamo effettuare per capire quanti chilometri, le emissioni e quindi redigere poi anche annualmente i cosiddetti bilanci di sostenibilità. L'utilizzo di questi dati poi è principalmente utile anche allo scopo di migliorare quelle che sono le linee di trasporto principalmente urbano, anche in base alla frequentazione, quindi eventualmente la presenza di utenti di servizio più o meno importanti a livello di flussi, quindi magari le fermate più utilizzate e così via. L'obiettivo a medio-lungo termine appunto è quello di sfruttare la sensoristica a bordo mezzo, che in questo caso ci viene fornita tramite server regionali, e quindi sfruttare questi dati e alimentare un server, una piattaforma che ci permetta di leggerli in maniera consona, quindi capire i chilometri, gli autobus circolanti nel bacino della provincia, valutare i dati in transito anche in tempo reale. Secondariamente ovviamente è anche l'informazione all'utenza per capire dove si trova un determinato autobus, quindi sfruttare la possibilità data dalla piattaforma che è stata descritta egregiamente stamattina, precedentemente, appunto anche con i dati dell'autobus, e quindi questo è il nostro obiettivo futuro. Grazie.
Grazie. Thank you. Paolo Veronesi, ARPA e Emilia Romagna. Please.
Buongiorno, io sono Paolo Veronesi, mi occupo dell'unità valorizzazione dati e patrimonio informativo di ARPA Emilia Romagna ormai da qualche anno. Sono un biologo e quindi magari può sembrare strano che ci occupiamo di cose informatiche che tipicamente riguardano l'informatica. Crediamo che comprendere anche le matrici di cui si parla, di cui accumuliamo i dati in queste nostre risorse, possa essere un punto di partenza importante per poi organizzare meglio i dati. Prego. Ok, essenzialmente abbiamo un portale che si chiama dati.arpae.it, su cui abbiamo i dati questa qua, abbiamo i nostri dati di tutte le matrici che andiamo ad analizzare. Tipicamente abbiamo dati in real time, che sono quelli che arrivano dalle reti regionali che producono dati in real time, per esempio la rete regionale della qualità dell'aria, sono in realtà in real time, ma li pubblichiamo a seguito di validazione. Quindi hanno vari step di validazione successiva che a seguito della validazione finiscono sul portale. Abbiamo invece serie temporali di dati riguardanti le matrici aria, le acque superficiali, le acque sotterranee, le acque di transizione e marine, che vanno indietro di 10-15 anni, e dati meteorologici che invece vanno indietro di 60 anni. Pubblichiamo anche i dati previsionali, in genere da modelli matematici, quindi questi sono dati più recenti che abbiamo dagli ultimi 5-6 anni e che pubblichiamo quando facciamo le previsioni, quindi per i giorni successivi, e poi archiviamo per i controlli degli altri utenti che magari vogliono fare una verifica dei loro modelli in base ai risultati dei nostri modelli. Gestiamo centralmente la metadatazione e la pubblicazione dei dati, aggiorniamo automaticamente molti di questi dataset e avviene l'harvesting automatico dalla regione Emilia Romagna di tutti i dati che stanno sul portale CICA. La successiva, grazie. Le nostre idee per il futuro, che in parte abbiamo già implementato, sono sicuramente cercare di pubblicare tutto sul portale Developers Italia, tutti gli script e le modalità di valorizzazione del dato di cui ci siamo dotati e di cui ci doteremo. Abbiamo acquistato in questi mesi con i fondi PNRR dei droni aerei, ne abbiamo 5 a questo punto, abbiamo un drone marino che utilizzeremo per fare mappatura tridimensionale e andare sul dettaglio di sorgenti che di cui normalmente conosciamo poco, o che magari possiamo vedere dal satellite, ma la cui risoluzione è piuttosto scarsa rispetto a quello che ci può servire. Implementiamo una rete di smart sensor con dati in real time, ne abbiamo comprati una trentina di varie marche e analizziamo questi dati con algoritmi di intelligenza artificiale. Fra l'altro abbiamo in corso un caso studio che si occupa dei cambiamenti climatici e del cambio di fioritura nelle piante, e anche una collaborazione con la regione Emilia-Romagna proprio per l'analisi con l'intelligenza artificiale dei dati degli smart sensor. Grazie.
Grazie. Thank you. Now, Stefano Livucci, area dati, settore innovazione digitale.
Buongiorno a tutti, anch'io sarò abbastanza breve. Regione Emilia-Romagna gestisce un'infrastruttura di dati geografici che espone una serie di dati, di dataset prodotti dalla pubblica amministrazione, dalla Regione Emilia-Romagna in particolare, nei vari diversi settori, ed espone anche un catalogo dei dati soprattutto. I dati sono spesso esposti dall'area e dall'infrastruttura geografica attraverso dei servizi OGC, VMS e VFS, ed è questo di cui noi ci occupiamo, quindi produciamo dei dati, gestiamo un'infrastruttura dati per tutti i settori della regione Emilia-Romagna e spesso adesso inizia anche a essere utilizzata da alcuni enti locali, e rendiamo fruibili i dati attraverso i servizi di fruizione geoportali ed applicazioni WebGIS. Questo è un po' il lavoro che noi facciamo. In questo senso noi, appunto, siccome pubblichiamo dati essenzialmente prodotti dalla pubblica amministrazione intesa come l'ente regione Emilia-Romagna, non abbiamo molta esperienza come ente nella produzione di dati dinamici. Abbiamo alcune attività, ad esempio l'esempio che posso portare di un potenziale dato dinamico è quello delle centraline legate ai flussi di traffico, che sono comunque dati rilevati ad ogni ora come frequenza temporale e che sono attualmente disponibili ma non esposti come servizi. Quindi questo potrebbe essere un esempio di dato che potremmo trasformare in un dato dinamico esposto. Ci sono altri potenziali dati raccolti nel corso di indagini statistiche che formalmente l'ente deve fare, oppure anche c'è uno studio su ricavare dei dati da quelle che sono le pratiche amministrative, quindi dati raccolti anche dai sistemi SAS per esempio, quindi in tempo reale. C'è il problema dell'esposizione, del seguire le normative, ad esempio della privacy, per esporre questi dati. Peraltro noi invece cercheremo di svolgere il ruolo di collettori, quindi di un'infrastruttura e di un catalogo di dati geografici che stiamo intendendo non solo come ente ma come territorio, e quindi cercare di veicolare opportunamente catalogati anche i dati prodotti ad esempio da ARPA che sono appena stati citati, con i quali naturalmente c'è una strettissima collaborazione. Già adesso noi gestiamo un'infrastruttura di dati entro e compliant con il repertorio nazionale dei dati territoriali e con Inspire, per intendere, che espone attraverso i servizi OGC i dati e espone anche i metadati. Su questo vorremmo portare anche eventualmente, insieme ai colleghi di ARPA ad esempio, dati dinamici. Per noi questa è una sfida, è una cosa nuova, quindi siamo molto interessati al workshop e ai contenuti che sono stati esposti, e anzi ringrazio dell'invito a partecipare. Direi che questi sono gli elementi essenziali.
Grazie. Luisa Vaccaro, ISPRA.
Sì?
Sì.
Eccomi. Buongiorno a tutti. Good morning. I'm Luisa Vaccaro and I've been working for ISPRA since 2000. ISPRA is the Italian Institute for Environmental Protection and Research, and it is the national reference institution for the SNPA SNPA is composed by ISPRA and regional and provincial agencies for the autonomous provinces for the protection and of the environment. And SNPA was established with the law, a national law 132, the number 132 on 2016. I work in the service that in ISPRA deals with the SINA, is the National Environmental Information Service, and the task of the SINA are mainly collecting, processing, and disseminating environmental and territorial data, and providing official data for public administration, and producing indicators, time series, near real-time data, and linked open data. Data and geographic information collected by ISPRA and SNPA are stored and made public and accessible also in near real time at web address here shown. And the data are published as part of the SINA, which guarantees, as a rule of that guarantees the effective link between the initiatives implemented by the various subjects in the collection and the organization of data, and guarantees the consistent maintenance of the information flows and the divulgation of data to the public administration, to the researchers and the experts, and to all the citizens. Among the dynamic data with the high updating frequency, there are the near real-time data about air quality and the linked and open data related to dynamic data of national web matrix network and national tidal network. The data gauges are placed in ports and measure parameters such as air temperature, humidity, water temperature, and its pH hourly. The buoys of the wave measurement network are also located offshore and use the parameters such as air temperature, the humidity, and the sea surface temperature, and wave hourly. The web application for near real-time air quality data is instead published at website address here reported. It presents data on 7 main pollutants for every monitor station. It's possible to access to hourly data in near real time with a delay of 2-3 hours. For daily parameters, that are the particular matter ones, it's possible to access to data related to the last 30 days. In download area are available CSV files for each region and pollutant. And moreover, as regards linked open data, all data sets are published according to RDF standard, which can be consulted with the Sparkle endpoint at the web address here indicated. Near real-time data, hourly updated, are available in CSV format at this web address. Then, the third slide, some ideas for future for the two type of data, linked open data, also taking into account the activities of the Department of Digital Transformation, of the presidency of the Council of Ministers of Italy. ISPRA will publish the ontologies that can be modeled, the observation, the indicators, and then the measurement station associated with a generic environmental dataset. For what concern real-time air quality data, during the next few months, ISPRA will publish the data on real-time air quality based on data models that are SPI compliant with the standard of SPI and available through appropriate API. At the same time, the related metadata will be submitted in the National Directory of Territorial Data of AGID, Agency for Digital Italy, or the RNDT catalog. It's all.
Thank you very much. Stefano Livucci, I think we already, yes, sorry, it's a mistake in my slides. Okay, so I think all of you have presented. Thank you very much. Maybe I had the, yes, just to double check, okay, great. So we can pass to the following part about the presentation of European projects, and if there is anyone else also from public administrations in Italy who has not shared maybe the slides but wants to add something about these, maybe we can do a final round after these sessions. So now I'm taking the slides for projects. So here, and please, the first one, go ahead. Slideshow.
Yeah, do you hear me, see me?
Yes.
Hello, Mario here from No Center in Graz, Austria. I'm the Chief Scientific Officer of the DIACI project. Pier Giorgio from DataNext is also a partner in this project, and yeah, so the project is mainly evolving around indoor air quality. We are one of the 7 projects which was granted in this call, and the idea is to gather evidence on a large scale how indoor air quality is affecting mainly children's health. So we can go to the next slide. Yes, so we have several pilots and measurement campaigns in the project. Since we also have many partners, we are in total 18 partners, and one of the pilots is in Ferrara in Italy, driven by DataNext and Lab Service Analytica. Then we have a pilot project in Zagreb, Croatia, which is being conducted by 2 Croatian and 1 Greek company. So a Greek company who is also a sensor producer. Then we have also sensor producer and a pilot in Estonia. We have a campaign in Sevilla in Spain and one in Vilnius in Lithuania. And since we have so many kind of different campaigns at multiple locations and different sensor providers, it was an important aspect of the project to include data interoperability, and this task is actually being led by DataNext, by Pier Giorgio. So data interoperability and all of these standards, which we have heard today, are quite an important aspect, and we hope that all sensor providers will adapt to those standards so OCG, and apply them in their kind of the daily operations. So all of those data should be uploaded one day to the Joint Research Council. Yeah, okay, my other things are now popping up. So we, besides kind of having sensor data, we also have metadata, which is quite relevant, so regarding buildings, etc. And yes, one of the main challenges is to how to deal with individuals or personal data, so occupancy, behavior, etc. Also according to GDPR, and how to align all of the sensor producers to adapt to those standards and to have a nice workflow for all. Thanks for your attention.
Thank you. Now the next project, Highlander and Sebastian. Giovanni Vignali, please go ahead.
Good morning to everyone. I'm Giovanni Vignali. I'm a computational biologist from University of Tuscia, and I thank you, the Usage Project, to invite me today for this workshop. Today I will present you the Highlander and Sebastian European project. The main focus of Highlander is the animal well-being, and to ensure the animal well-being to prevent the impact of climate change. For example, as we all know, climate change are producing more and more frequent extreme events. For example, a heat wave during summer. For this reason, we are developing, using IoT, new tools to help farmers to challenge this event. Next slide, please. How our IoT system is working. We are using sensors which are positioned on different parts of the animals, and each sensor is reading specific data. For example, we have a collar which is reading air temperature and humidity. All this data from the sensor are collected from the animal main device, which will publish this data on the first server. The first server will collect the data from all the sensors, store them, and organize them. This data can be visualized through a Grafana dashboard. This data can help the farmer to the management of the animal. For example, as we have seen before, and its stress during summer. This sensor have a public license data which is available on the Highlander data portal. Next slide, please. And which are the plans for the future? Since Highlander is recently ended, we are continuing with Sebastian project. So our objective is to increase the number of animals which are monitored. For example, Holstein breed. We will include new type of sensor. For example, a skin temperature. We will also create a system for real-time warning. And all these sensors will also be used in the framework of the Agritech project. Thank you very much for your attention.
Thank you very much for your presentations. Now Joan Mazo has to leave us, so since I'm not stressed enough today, I'll try to say a few words about AD4GD as well. So this is an Horizon project, it's a sister project of Usage, and I'm talking about it because OGC is also involved in this one.
I wonder if you hear me?
Yes. Hi, Joan. Please.
Okay. I'm in the train station, so I don't know how long I can do that. But anyway, yes, you say it. This is a project that should help develop the Green Deal data space. The Green Deal data space is an idea of the Commission. They really want all this data that can be used to assess the Green Deal available from one place. And well, that's the challenge. So what we want to do is actually work in defragmenting the actual environment of data, but also exactly. Thank you very much. So our proposal is about to try and make more data openly available using the building blocks created by the OGC and so on. Some of them are standards, and also integrating the SensorThings API actually. So it's about integration. We should focus on the end users. Our solution is about using interoperability, but not only at the service level, but also at the semantic interoperability level. Because if we want to integrate data that comes from citizen science, for IoT and remote sensing and in situ and so on, we really need to understand each other. So semantics is going to be key. It is also being key the trust on the data. So data quality descriptions should be there. If you go next now. I will present those use cases. Actually, we have 3 use cases. There are one use case in Berlin. This is about water quality in lakes. So what we are going to do is in situ measurements from IoT and citizen science. We are going to do biodiversity dynamics and corridors in the Mediterranean, in the metropolitan area of Barcelona. In here, we will have in situ, we will have IoT, we will have citizen science, but we also will have remote sensing, maybe for land cover change. And finally, we have an air quality that most probably is going to happen in the northern Italy with low-cost sensors mounted on DHL trucks, but this is still to be confirmed. So if you go next, you will see that, okay, that's the one. We have these tasks on integrating different things, and in particular Internet of Things and citizen science is where the SensorThings API could play a role. But there are difficulties, and the difficulties are the IoT people, they have their own stuff. So they talk about FireWire, and they talk about TMF and other standards that I actually don't know a word about them. So I really need to find out, and this is one of the challenges. We will see how we could harmonize that with SensorThings API or use it together or whatever. And in citizen science, we also have challenges because in citizen science we need the presence of the citizens. And if you remember the diagram describing the different objects in SensorThings, there is nothing to describe the individual person that got the data. There is nothing to describe your license that could be different from each user. So this is something that we have been working on best practice, that you have the URL there, suggesting some improvements and extensions that we also implemented in the Frost implementation. We call it Frost Plus, and you can have it on the Secure Dimensions GitHub. Next. And I wanted to trick you into another slide that is a completely different project. This is something called CityOps. This is a project that started just, 2 or 3 days ago. And it's all about SensorThings API. If you look at the diagram, you will be able to spot that protocol here and there and everywhere, because, again, we want to use SensorThings API as the glue that holds all these data sets that different citizens in air quality are producing. But as I said, we are at the beginning, so we are trying to convince the different actors that's the right thing to do. So we will see what happens. I will tell you in 2 or 3 years. And I believe that's all. Thank you.
Thank you, Dan. Now we still have usage. Here, Oscar coordinating is here in the room. Yes, I will take it. Yeah.
So do I have to talk to the microphone? Or
yes, you have to come here and talk to the microphone.
And interested to see the definition of the Green Deal data space that usage has. That might be a little bit different from mine.
Exactly. We were talking about this, Joan. We will still have to talk a little bit more.
Okay, please, stage is yours.
From this, I mean, like, in very simple terms, I mean, I have been creating this right on the spot, and I will only use examples from the city of Zaragoza because we already were talking about this a few days ago. I can go, no? Over here, yeah? Okay. So, which are... Open the camera. Oh.
So they can see you.
So they can see me. Hello, how are you? So basically, I mean, like, I have taken just examples of some of these sensor data sources that we are going to be using. From the case of Zaragoza that we were discussing, and we have been going through the data catalog all these days as well. I mean, like, trying to refine it. And this is just an example of things that are going to also happen in the other cities that are involved in usage, which are Ferrara, Graz, and Leuven. So, I mean, we have over here as examples air quality data, yeah? Both the data that we sense and the data that we predict, yeah? And this will be something that we will be looking into because, I mean, it may be a nice case also for the SensorThings API. We have also another interesting area on heat islands. Again, I mean, like, this is taken from both in situ observations and from the processing of Earth observation data. And again, I mean, it's something that could be provided from using this type of API. And finally, in terms of environment, we will be working with the noise maps, yeah, according to some of the existing directives. So I have a little bit more detail on each of these ones, but I mean, it's just for the purpose of like showing them. I know. I mean that we are a little bit pressed by time, but I mean, just to give you an idea, this is the current visualization. Nothing really strange in that sense. I mean, it's not using any specific API for the time being. It's only a data set that can be used, I mean, to access observations. In terms of the predictions of air quality, they want to go much further, not just the weather, the stations that are used for air quality, but also, I mean, applying models that can obtain like a little bit more detail, fine-grained detail on the air quality in different streets of Zaragoza. And I mean, this will be starting to be available by the end of this year. And it's part of the compromises, yeah, of the city council. In terms of heat islands, you can just see, I mean, that it is also starting right now. I mean, they are having now a WMS service, and they are also thinking about how to provide the data in a better manner so that it is more reusable. For the time being, it's only like a map, a layer, yeah, that you can put, you can click, get some piece of data, but that's all, yeah. And finally, in terms of the noise maps, again, I mean, this is a need that they have recently identified. This is very related to one of the regulations where they should be providing this data with many more updates or much more clearly. And I mean, they will be working very fast on this because they know that they are already late. Yeah, I mean, so they had some work that they were doing in the past, and they will be seeing, I mean, how this can be done in a better manner. So this is all that I wanted to comment. I mean, I can just go back into the main list of sensor data, and that's all. Yeah.
Thank you very much, Oscar. Any question for any of the speakers so far? So if not, we can try to do this. So we still have half an hour, so we are surprisingly in time, and we can use this half an hour for the discussion as was foreseen. So please go to menti.com and use this code. I can pass it in the chat. Where is the chat? Here. And we can really make some more guided discussion. Unless you have any comments to tell, in that case, please feel free to open your microphone and speak. Yes, can you? It's in the chat, 47963482. Okay, it's also here in the slide. Okay, so first question is what are about the obstacles that must hinder the SensorThings uptake in your organization, and we are mostly interested about the opinions and the views from public authorities, of course, or yeah. You can answer in English or Italian, as you prefer, so no worries about that. Some more answers. I also pasted here. Okay, so I will a few more minutes, like 1 more minute, and then we can open a bit the discussion about around these answers. So ignorance about the standard is popping up. So that's good for justifying the workshop of today and a good ground for the OGC Academy starting, I would say. Then we have right implementation, organizational aspects and issues, data sources, mapping data models. Okay, so I would invite you to comment on these results. So maybe, for example, I'm rather curious about what are the organizational problems and issues and aspects that are there. So, quali sono I problemi di organizzazione che sono più importanti, e più difficili da superare? So, what are the major issues about that? Can anyone answer this and elaborate a bit on this? Please don't be shy.
Maybe we need to be more specific about what organizational means.
Yes, that's what I would like to know.
Yeah, that's why I'm not intervening because I'm uncertain which kind of organizational stuff we are talking about. Are we talking about procurements in the organization? Are we talking about the people that don't know how to deploy that? Are we talking about how to organize the data? I mean, all of these things could be, barriers.
Ok, quindi chi ha scritto problemi di organizzazione, se ha voglia di raccontare qualcosa in più, sarebbe benvenuto. Otherwise, we can elaborate more on other things, like, for example, data sources. Why data sources is an obstacle? In what sense? What do you mean? Okay, so please, may come here. We have it here on the audience.
I wrote it, and I meant like data availability from the data producers, that every data producers, if they don't adopt common standards in making the data available, it's more difficult to make the matching with the SensorThings API.
Thank you, Raniero. Anyone wants to comment on this?
One thing that I could say is that most of the sensors actually don't talk SensorThings API. So this forces us into somehow adding a different layer that translates the sensor protocol into something else. So maybe we need the sensors that are writing to the database using some kind of a back protocol, let's call it a backdoor, and then we have the SensorThings API offering the data from the other stream. And so there should be some kind of a different ways of doing this connection, and I believe this is the most difficult part. Sensors are becoming more and more intelligent, so they have internet, they have capacity for processing and so on. So these things could be overcome by using, I don't know, the MQTT protocol or something like that, that is also integrated in SensorThings. But I believe we need to work more on these aspects.
Thank you, Joan. Final step, invitation to Italian audience. Quindi un invito in particolare ai nostri ospiti italiani a condividere opinioni, commenti riguardo a questi aspetti.
Beh, allora Stefano Livucci, Regione Emilia-Romagna, provo a dire qualcosa io. Come dicevo prima, come ente regione, tipicamente un ente regione è un ente di programmazione, però come sta succedendo negli ultimi 10 anni, cominciamo anche a essere enti che producono dei dati territoriali e geografici o coordinano la produzione e la divulgazione di dati. Quindi da questo punto di vista c'è un interesse molto forte a conoscere molto meglio gli standard, ad assumere competenze, come è scritto qui nella slide. Credo almeno in Regione Emilia-Romagna ci siano meno problemi di organizzazione, soprattutto nelle relazioni con altri soggetti come le agenzie ARPA che ha partecipato oggi, che producono dati dinamici, problemi di rapporti non ce ne sono, ma dobbiamo essere molto più bravi a cercare di utilizzare questi dati e veicolarli anche verso altri soggetti che magari ne hanno bisogno e stanno immaginando iniziative di utilizzo per magari fare analisi particolari o creare dati a valore aggiunto. Peraltro c'è un forte interesse come ente Regione Emilia-Romagna anche in tema di innovazione nell'elaborazione dei dati, quindi anche dell'approccio big data, quindi i dati prodotti in tempo reale sono di estremo interesse. Al momento dobbiamo assumere competenze, quindi è molto importante che sia annotato nella slide questo aspetto della conoscenza degli standard e delle competenze in merito, perché per noi come ente è proprio un aspetto focale, mentre invece sugli altri temi ci riconosciamo insomma abbastanza pronti a lavorare anche in questo settore.
Grazie, sono aspetti molto importanti sicuramente da considerare per promuovere l'utilizzo di questi standard, che sicuramente hanno dei vantaggi e dobbiamo appunto considerare tutti gli aspetti, non solo il lato tecnologico. Qualcun altro vuole aggiungere qualcosa, commentare ulteriormente?
Se posso, Antonio Rotundo.
Certo.
Parlo in italiano, sì, magari è meglio. Riguardo alla disponibilità di dati, secondo me un impulso potrebbe essere da queste, diciamo, nuove regole che stiamo definendo in Italia, ma che sono poi stabilite a livello europeo con la direttiva Open Data, nel senso che, come dicevo prima, i dati dinamici, quindi dati anche rilevati da sensori, sono una delle categorie di dati che a livello europeo e ovviamente a livello nazionale sono identificati come dati ad elevato potenziale socio-economico, quindi da rendere disponibili obbligatoriamente, e quindi con queste regole ovviamente per le pubbliche amministrazioni, ma anche per gli altri soggetti che comunque gestiscono un servizio pubblico in Italia, c'è l'obbligo di renderli disponibili, e la direttiva aggiunge ovviamente disponibili immediatamente dopo la raccolta, perché è chiaro che il potenziale anche a livello informativo è tale se il dato viene reso disponibile subito, cioè se viene reso disponibile dopo tempo che è stato raccolto, chiaramente l'utilità di quel dato viene a diminuire. E in più, quindi questo sulla disponibilità dei dati, io credo che ci sarà anche un aumento di disponibilità dei dati con, credo, una qualità maggiore, perché poi in queste linee guida che citavo diamo comunque indicazioni anche sia sugli aspetti organizzativi che sulla qualità dei dati, in modo tale da rendere disponibili dati di qualità, ovviamente, che possono essere riutilizzati, ma anche, se non ricordo male, si citava anche in una slide stamattina, per quanto riguarda il licensing framework, perché in molti casi i dati che vengono riusati non sono integrabili, perché sono soggetti a licenze diverse, che non sono in alcuni casi compatibili e quindi non possono essere integrati. Con le linee guida si definisce un licensing framework abbastanza chiaro, che si rifà poi alle indicazioni della Commissione europea, quindi CC BY 4.0, quindi con la sola condizione dell'attribuzione, senza altre condizioni per riusare i dati, o in alternativa CC 0, quindi il pubblico dominio, per cui possono essere utilizzati senza nessuna condizione. Per quanto riguarda la conoscenza degli standard, come dicevo, praticamente noi nelle linee guida abbiamo inserito per ciascuna sezione delle risorse utili che possono essere, a cui bisogna fare riferimento per implementare poi le indicazioni che diamo nelle linee guida. Una di queste risorse utili è proprio lo standard OGC SensorThings API, e poi nello specifico ovviamente la good practice definita nell'ambito di Spire. Quindi chi si trova a implementare le linee guida per quella tipologia di dati ovviamente è invitato, la raccomandazione è di utilizzare ovviamente e fare riferimento a quella good practice, e quindi utilizzare lo standard OGC. Quindi probabilmente le linee guida possono essere anche queste uno strumento per far conoscere gli standard che sono disponibili per i vari aspetti, diciamo. Per finire, come Agenzia per l'Italia Digitale svolgiamo anche un ruolo di formazione su questi aspetti, facciamo abbiamo organizzato sia lo scorso anno che in questo anno che è appena iniziato diversi cicli di webinar su cui appunto approfondiamo tutti questi aspetti. Come dicevamo, insomma, anche nei contatti che abbiamo avuto nelle scorse settimane, potrebbe essere anche questo dell'OGC SensorThings API uno dei temi da trattare nei prossimi webinar per le pubbliche amministrazioni italiane e per gli altri soggetti interessati, considerando che in genere abbiamo numeri elevati di partecipanti, iscrizioni intorno a 700-800 iscrizioni, poi ovviamente i partecipanti effettivi sono intorno a 500, quindi può essere una buona platea per fare divulgazione e formazione anche sugli standard. Grazie.
Benissimo, grazie per questa visione e anche prospettiva verso un po' gli sviluppi futuri. Passiamo ancora all'ultima slide di Mentimeter. Forse. It's not switching. Yeah. Okay, here. Next slide. Okay, here is about ranking. So, what is the help that is needed? It will be probably in line what you already discussed, but also what is the most important one? We took these entries from the questionnaire that we have shared with you before this workshop. So yes, the questionnaire is still there. So if you would like to add anything there, you are welcome to do it, and we'll use it in we'll use the results and answer in our following reports and reasoning about action plans. Oh, nice. There is rather clear ranking. I'm not sure if you are able to see the results clearly. I can try to do that, more or less. So first, digital skills. That's clear. Okay, so we have to work towards it. No, it is changing. It is changing. So clear policy directives is also at the first / second place. So now it got to the first. Chiara indicazione nei documenti di policies. So we really need to to work together with decision makers and administration entities in order to influence influence the policies, or at least to have a clear exchange and to be aware of the potential of the standards and of the advantages that can be brought to the policies. And this should be clear. Digital skills, yes, okay, definitely, it's jumping again up. At third place, we have human resources. So yeah, okay. So it is something. I think this list is also interesting for the entities that are in the public administrations and public institutions. That's also where to invest and where to direct the efforts of the next times, probably. So more human resource or different additional human resources, digital skills, policies, already considering the technology which is there. Technical rules, standard implementation tools. Okay, today we saw a range of them, and they are still under development. So more will come, but of course that's a critical point. Understanding interoperability services, features, and use, which goes also as part of digital skills, software and technologies, a strategy. Okay, a strategy, it's something needed, and understanding the potential and applications, not limited to one kind of data. It's rather the end. So I assume that we have clear understanding of potential and applications of this, which is presented today. Anyone want to comment on these? Any comment? Any question also to the speakers of today from the ones remaining in the meeting? In Italian is okay. I'm also addressing the same question to the audience here, so if you have any question and comment, okay, please, Pier Giorgio.
Very shortly,
Please
I think, in my personal opinion, the first support needed in terms of clear policy directives, indications, I think that what Antonio presented, even though not yet available because under development, but the section on the guidelines with reference to material and to us very clear indications already provided by Agid can fill in this gap. So I'm quite optimistic. Of course, today this is happening because all this material is not fully available, and when will be available, it's not probably so easy to digest, but I think it's a good support. In terms of digital skills, of course, the path to fill in the knowledge and skill gap is a bit more long to cover. Just this consideration to share.
Thank you, Giacomo. Any other comment? Commenti anche dagli ospiti italiani? Oltre a quelli condivisi nella slide precedente. So it seems that, okay, no one else has anything to share more. We have a clear result from the meeting of today, I think. We are all hungry as well. So I would conclude the workshop here, and thank you very much to all of you for your presentations and participations and input to the meeting. And yeah, have a nice day, and thank you all. Bye.
Bye. Thank you to you.
Bye bye.
Thank you, everybody.
Bye. Bye. Thank you. Thank you very much.